Hi everyone, I'm Santosh. Welcome back to my channel, MLearners. In this video, I'll be teaching about a very important topic, okay, which is data science lifecycle. So, before moving on to what exactly is data science lifecycle, let's ask very important question. So, why this topic is very important, right? So, first of all, machine learning and data science is not about building models. So, many beginners has the thing in their mind that everything is about models, algorithms, and whatever the thing is, algorithm will give the good results, right? So it's not like that. So data science is multi-stage and multi-step process. Not only data science, for that matter, there is something called as SDLC. So software development life cycle. Even they have their life cycle there. So some of the stages in that life cycle is similar to data science life cycle, or we can say we have took some of the stages from a software development lifecycle and integrated that as part of data science lifecycle, because at the end of the day our problem is to solve a business need, right? And that requires certain stages like testing, deployment. So similar to software development lifecycle, right? So these are the reasons, like one of the reasons, right, why we exactly need data science lifecycle, right? And moving on to the points. So the first point is this topic acts as a roadmap on what data science is all about. Each stage in this life cycle acts as a module unto itself. It's a very important point, right? Very important point. It's very important. The second one is it helps a beginner clearly understand where to start and how to proceed step by step without confusion. Like, let's say you're given a problem statement. As a data scientist, it's your job to solve that problem and meet the business requirement. And if you're not sure on data science lifecycle, you may end up solving the wrong problem statement and the wrong business need. So if you're aware of data science lifecycle, it helps as a what we call a power for you to ask a right question to the business people, so that you will get the required things from them, right? The third point is it gives a structured approach to solving real world problems using data rather than jumping randomly between the techniques, right? So if you know this life cycle, it becomes easier and structured, and you will follow a structured way so that you will not get confused or you will not get lost between different techniques, because data science is very vast field, right? It involves a lot of techniques from data analysis, it involves a lot of techniques from data engineering, data mining and all. So all these techniques we are trying to use it for our need to solve particular problem statement. So if you have lot of things at our hand, it becomes very hard for us to choose which technique or which process to follow, right? And let's see, if we don't follow our data science life cycle, what will happen? If you don't follow, one of the main thing which will happen is we may solve the wrong problem statement. So I think we already discussed, right? We may use incorrect data, we may build a model which will fail in production, we may fail in iterative improvements, right? So all this, don't worry, we will discuss all these 4 points in the further of this video, because each points here are linked, and we will be discussing when we are discussing each stages of this data science lifecycle. Okay? So moving on, what exactly is data science lifecycle, right? It's a step-by-step process that helps turn data into real-world solutions, right? One of the most widely accepted structures for managing analytical problems is the cross-industry standard process for data mining. So there is this step-by-step process which we need to follow, right? And this step-by-step process is given by something called as CRISP-DM, right? Which stands for cross-industry standard process for data mining. So they have took some of the concepts from data mining and use that for data science, right? So that's what they are saying. So this is the concept of data mining, because data mining is where you'll have tons and tons of data. So there should be some structured process to analyze and get some insights out of it. So they have developed some structured process, and that structured process we are also integrating into data science so that our problem statement becomes very easy to solve. Correct? And if you see what are the stages, to briefly summarize the stages, the first stage is understand about data, explore about data, prepare the data, and that data should be inputted to a machine learning algorithm and evaluate the outcome of that model, the accuracy and all, and deploy that model. So these are 6 stages, but we will clearly see in a detailed manner what each stage refers to, right? So for now, I think you have understood what exactly is data science lifecycle. It's a 6-stage or 6-step process, okay, which we are taking from data mining. Okay, so now we'll see exactly what are these 6 stages. So one is business understanding, okay, and data understanding, data preparation, modeling, and evaluation. So you have to start. So this is the first stage, okay, and this is a 6th stage. So you're going from first stage to 2nd stage and 3rd and so on until 6th stage. And also, not only that, if you have some problem in data understanding, you can come back and ask to the business like what exactly is the need, because you're not understanding particular thing based on the data. So it's like a iterative process. So you're going back and asking business that, okay, I need these columns, or there is some missing values, etc., right? There are some outliers. So it's like a iterative processes, right? Let's say your modeling is failing, you're not getting good accuracy, considering some errors. So what you'll do is you'll go back to data preparation, okay, and see where you have made an error, okay. So all these things is a defined process, right? So you will not, at the end, if you are following this structured approach, you will not get confused on what exactly you are solving, right? So moving on. Now let's see how each stage works. So first stage is problem understanding or problem or business understanding. So this stage is a definition stage of problem statement. When I say problem statement, I'll say you are solving a problem of predict the weather in the next couple of days for next couple of days using the past data. Then that becomes a problem statement, right? So that is what you are trying to solve, right? That is the first thing you will understand from this stage, right? So define the objective clearly, understand the business needs. So you will also need to understand businesses, like they have some certain KPIs, okay. So what is the key, or what is the indicator they are checking that we have solved this problem in a correct way or accurate way? They have certain indicators, so we have to know that indicators as well from the business. So that thing will come in this business understand. And the third one is understand the success criteria. So again, so the success criteria may be accuracy, or it can be time, cost. So mostly for business need, they evaluate any problem at the end of the day using time and cost and accuracy. All these 3 metrics are very important, right? And at the end of the day, there should be some savings, right? Savings in terms of time and cost, right? These are the main pillars of any success criteria for any business problem statement, okay. And here you'll ask the right questions. So once you know and understand the problem statement, you should ask the right questions. So this is a stage where you will ask the business people, where can I get the data from? What is the time to deliver this project, etc., all these things you will be asking in this stage, okay. This is about problem and business understanding. Let's move on to second stage, which is data understanding. So data understanding, here once you understood the problem, this is the second stage. So the first thing is collect the data from different sources, right? So once you understood the problem, now it becomes easier for you to understand what type of data you will be requiring to solve the particular problem statement. So you'll be asking them, okay, give me the DB access, get the data from APIs or any files. So different data according to different needs and use cases, you'll be collecting data from different stages, or sometimes the data is already available for you. Okay, so all these things you will do in data understanding stage. The second point is understand the data structures, right? If your problem statement requires structured data, you'll know what are rows, what are the columns, what are the different types of data you are available. Like you are dealing with categorical or you are dealing with numerical data. Okay, so all these things you will be understanding in this stage, right? Perform EDA. So EDA refers to exploratory data analysis. Don't worry, we will discuss this in the future. So here, to simplify, you will understand the data by looking onto the graphs. You will be plotting different graphs using Python or different tools like Tab. So you will be looking and plotting different plots with respect to maybe output variable or with respect to the input variable itself. So all these things you will be doing in the data understanding stage as well. Okay. So the fourth point is identify missing values, outliers, inconsistencies, etc. So some of the important tasks like filling the missing values, like all the rows, let's say, will not be available, like all the values in the rows. Sometimes the values will be empty, sometimes it will be like some outliers, like instead of 100 they have let's say instead of 100 like this, they have noted it as like 10,000. So this is an outlier, right? So you will try to understand all this when you plot the data, right? So all these things will come under data understanding. Okay. Second. So the fifth point is understand relation between variables. So there are certain techniques that you will be using to understand the relationship, like collinearity, etc., etc. So all these things will make you understand, okay, what feature to select, what to reject, and all. Right. The final goal of this data understanding stage is know your data before using it. Right. That's the main goal of it. So moving on to third stage, which is data preparation. Okay. The final goal is to use the data for modeling. So different machine learning different models accept different types of data, right? So whatever the data you have to convert that data into the model compatible way, like machine learning algorithm compatible way. So all these things you'll be doing in data preparation. So one thing is that finding all the missing values, whether you have to fill the missing value or you have to completely reject that row. So you have to decide based on the problem, right? So remove the duplicate rows. If you have any duplicate, let's say you have two rows having the same values, you will be rejecting one of the row out of it. Okay. So convert data types like text to numeric and date formats, etc., etc. So at the end, the models will take the input as numeric values. So you have to convert each and every type of data, whether it be images or text or anything, to numeric format. Okay. So normalize the data, right? So create select important features. So this is also important. So you have to select and reject useless features. So there is this splitting. You have to split your data in accordingly, right? So you have to put some part of data. Let's say this is your whole data. You have to put some part of data for training your model. So you have to train your model, right? Machine learning model, and you have to test on this data. So this part is for testing. So you have to allocate the data accordingly. So that thing also you will do in data understanding. Okay. I hope you got these three stages. So moving on to this, the favorite stage of the people, which is modeling. So here, this stage this is also a very important stage, but predominantly you will be spending 80% of your time onto the above stages. Okay. So 1, 2, 3, 4. If you consider only these 4 stages, you will be spending 80% of time in these first 3 stages. and you will be probably spending only 20% of your time here in modeling. Okay, that's why these 3 stages, or at least this second stage and third stage, will take your a lot of time. And these 2 stages, second and third, is like an art part, right? The better your analytical skills, logical skills, the better you'll perform these 2 stages. And these 2 stages is a backbone for your modeling to be good or not. Like if you have selected a particular model and you are evaluating that model, if that is not giving good results, again it depends on these 2 stages. As I said, the garbage in and the garbage out, right? So whatever the input is, that's how the output will be. Even though the better the model is, if the input is very bad, you will not see the good results at the end. Okay, so that's why they say that it's the art part, okay, of doing data analysis and all. Okay, so select suitable algorithm. So you'll be having different algorithms, like whether you have to go for deep learning or machine learning algorithms. You have to choose from this. You will be choosing that in this modeling stage. So train a model on training data. Try multiple models if needed. So there are certain things, right? A lot of people try different models and see which models are working better. It's not like randomly selecting the model, but you have to know the mathematics behind the model, and then only you can select the good models out of all the models available, because you can't keep on training all the models. It will just waste of resources, right? And tune hyperparameters. So there are certain hyperparameters, let's say in KNN, which is one of the algorithm. In that KNN you have a hyperparameter called K, where it says how many nearest points to select and all. So that thing you will do in this modeling stage, right? Tune hyperparameter. And the third one and the final one, handle overfitting and underfitting. So we will discuss about overfitting and underfitting while we discuss in the modeling part, machine learning algorithms. Okay, this overfitting and underfitting is one of the biggest problem in the modeling in machine learning algorithms. So you have to always try to balance this overfitting and underfitting. Okay, we'll see their definitions in the future. Okay, so the main goal of this modeling is build a model that learns from the data that performs well in the production stage. Okay, when I say production, it means that it have to perform good in real world scenarios. Okay, so that's about 4th stage. Coming on to 5th stage. So if the 5th stage is evaluation. For this stage, whatever the model you have built, you have to test that model on the data which we have splitted, right? The 20% of the data which is unknown to the model, right? So that acts like a real world tester. So you will test the 20% split which you have did the 3rd stage, where we already saw here, right? Here you have splitted your data to training test, right? Here you will take the test data, perform a real world predictions, and you will see how better your model is performing. You will know that your model is performing good. You will know that using metrics like accuracy, precision, recall, RMSE, etc. So these are different metrics available for classification and regression models, right? So compare different models. So you will do that here. Check if results meet the business objective. So as we see, there is this KPIs, right? So you will check those here itself. So if your model is meeting the business criteria, right? So validate all the assumptions. So there are certain assumptions you'll be taking while you are preparing the data using particular models. So everything has certain assumptions. So you will validate those assumptions while you are evaluating particular predictions, right? So at the end of the day, the main goal of this evaluation is to say how well you have built your model, not only just model, right? This evaluation stage acts as an evaluation for not only this stage, but also your second stage, data understanding, data preparation, modeling. So all these stages you have did so far, you will understand those things while you're evaluating. So everything will come into picture once you evaluate, right? So that's how this stage is. And moving on to the 6th stage. which is deployment stage. I think whenever a beginner data scientist or machine learning engineer, whenever they hear about this term deployment, they are very afraid, because deployment is not easy, right? So it has a lot of things, like we have to know the stack, like what the stack we should choose and all, right? Because till now we have did all the analysis in, let's say, Jupyter notebook. Right now we have to deploy that into some cloud, right? It becomes very hard for any beginner data scientist to make this system, whatever they have built, in a deployable way, right? So here in this stage, you'll make the model as an API. Okay, you'll deploy that as an API in, let's say, any cloud platform like GCP, Azure, and all. Okay, so you'll not only deploy that, you have to also integrate that deployed app or API. Correct? That's also important. So now you have built a model, or a machine learning model. Now the machine learning models are not as stagnant, right? They evolve. They have to evolve because the data will change over time. So let's say you have done your analysis today, and tomorrow or after a month, the data might be changing. So there will be a drift in the data. Accordingly, you have to check or create a dashboard where you can analyze your model performance over time and make that also an automated way, right? You have to make the monitoring and retraining of the model in an automated way, so that everything comes under monitoring performance over time, and also integrating the automation to retrain the model automatically, right? You can't keep on training the model manually, right? That's useless, right? Handle real time or batch predictions, right? So again, it is also a system requirement. You have to understand the load, how many users are using your model, etc., etc. All these things comes from all these things you will understand or handle in this deployment stage. So update, retrain model when needed. So we already discussed this point, right? So when you monitor the performance of the model, then only you can able to understand if you can retrain the model or if there is any need of retraining the model. So at the end of the day, use model in real world and keep improving. So that's the goal of this deployment stage. Okay. So don't worry, we will discuss all these 6 stages clearly, because each stage acts as a module, as I said. And one more question you have to ask, which is, okay, this data, what are the steps we have discussed? These steps predominantly are being used for structured data. When I say structured data, so those are rows and columns. What about GenAI, right? Where GenAI is about unstructured data, right? Like text, images, and all. So will this data science lifecycle suitable for those scenarios where the data is unstructured completely? Yes. Even the data, what are the data you're handling with, you have to have all these steps every time, right? So irrespective of the data type, or whether it is GenAI, deep learning, most of these stages applies for whatever the data you're handling, right? So I hope you understood all these 6 stage steps of data science lifecycle. If you have any doubt, you can comment down. Okay. Till then, take care and bye.